We're going to have a look at circles. They're particularly easy, really, except, of course, some can try and always think of something to make life hard, but not really that difficult. So a fairly short and easy topic to have a look at. Let's get into having a look at this and see what we can do. The first thing that we're going to want is any of these sort of circles. I'm going to use a template to try and improve my circle drawings for today. Is that when we're playing around with something, we might have a line. If I can find the center point of that line and I can draw a perpendicular to it, it's going to go through the center of the circle. If I take any other chord and I find again the center of this and project a perpendicular, these will meet at the center of the circle. So something that's really important then to be able to find here is, can we find a midpoint? And can we then work out here the next one, which is a perpendicular bisector. How do we find the midpoint of a line? So let's suppose I've got any line. We've got basically two coordinates, one at one end, one at the other. We have x1, y1 and x2, y2. So we need to try and find these. So the midpoint of a line like this is going to be our points of x1 plus x2 divided by 2, and the other one is going to be y1 plus y2 divided by 2, and that's going to give us a way of finding the midpoint. Once I've found a midpoint, then we can work out the equation of a line. Once we've worked out the equation of a line, we can work out its perpendicular bisector, simply because that's going to be the negative reciprocal of the gradient, and we then know a point where they go through, and therefore we can work out the equation of that line. Let's have a look and see what we want to try and do. So let's suppose we've got a line segment and we've got some points to this, and let's just choose a couple of points at random. Let's choose -3 and 8, and we'll choose something like 5 and 4. So let's go ahead and try and work out what those points are. So to work out those points, let's just zoom in a bit. We can simply say these are our x value, our y value. I'm sure you know that. So we've got here -3 plus 5 divided by 2, and we've got the other one, which is going to be 8 plus 4 divided by 2. So this is going to give us -3 plus 5 is 2 over 2, which is going to give me 1, and the other one is I'm going to get 12 over 2, and that's going to give me 6. So my coordinates for my centre of my line are going to be 1, 6. I've got my midpoint. What can we do once we've got our midpoint? Well, we can work out the equation of this line that we've originally got with these coordinates, and if we've got these coordinates, then we can work out our gradient, which is going to be y2 minus y1 over x2 minus x1. So if we work that out as being 4 minus 8 over 5 minus 3, which is going to give me plus 3, I've got here 4 minus 8 is going to give me minus 4 over 8, which is going to give me a gradient of minus a half. So if I want to work out my perpendicular, it's going to be the negative reciprocal. So if we work out this, so our perpendicular line is going to have a gradient simply of 2, and we know it's going to go through those points. So we've got our y equals 2x plus c, going through those points. Various ways of working this out, but one of the easiest ways is just to substitute in those numbers. So 6 equals 1 times 2 is 2 plus c. So here c is going to equal 4. So my equation of my line is going to be y equals 2x plus 4, going through my point 1, 6. So I have now worked out my perpendicular gradient, my line, the equation of the line, and I've got through that point. We do that again for another one, and that will give me another line that will go through. And then what we can do is we can solve this simply using a simultaneous equation to work out where the 2 points meet, and that would give me the centre of the circle. So midpoints, quite useful trying to find things in a circle. So we've got a circle, simple properties, we can use it to help us find all sorts of things. We can find it's a bit easier in some of them. Some of them can make life a little bit easier for us. They might tell us, for instance, we've got a diameter. If we have a diameter of a circle, then, and that's just done by eye, if we can find the midpoint of this circle, that will give us then the centre. So very simple, but very obvious. The midpoint of a diameter is certainly going to equal the centre. Once we've done that, we can work out all sorts of things to try and help us. One of the popular things that we have in these are something like this. If I take any circle and I draw in here any triangle, it doesn't matter what sort of triangle we try. if I take any 3 points on a triangle, which I could have drawn in any way I'd liked, any triangle that we draw, we can fit a circle round this, and this is given a special name, and this is called a Circum Circle. This is the Circum Circle of this triangle. And the center point will of course be the circumcenter. How would I find this? Well, since these are all chords of a circle, simply taking a bisector here, and let's bisect the next line, and let's bisect the last line. All of them will intercept at the center of that circle, which is quite useful really if we want to try and play around. So where do we start with some of these things? Well, if we want to try and play around with a circle, I suppose the most important bit is to have some idea about the equation of a circle. For any particular circle, we have the equation of a circle. If it's got a center of 0, 0, then this is a special equation here. This is going to be our x squared plus y squared equals the radius squared. Let's explain this. So I just chucked the ruler on the floor. Let's imagine that this circle does indeed have its center here. Yeah, I can see it's not quite. Now, to work out the radius, we need to have some sort of measurement in the x direction, and we need to have some sort of measurement in the y direction. And if I draw up here the line between those two, this will be the radius. So this is simply Pythagoras to do this, and very easy it is to do this as well. When we've got a circle that is not in the center, so let's give this a center of something like A and B, then our equation of our circle will be x minus a all squared plus y minus b all squared, and that again will equal the radius squared. So if I want to work out perhaps something really nice and easy, let's say we've got a circle and I'm told various things about the circle. So I might be told it's at 3, 2 is our center point, and it's got a radius, let's make it easy, of 4. Then to work out what this is going to be, it's going to be very easy. It's going to be x minus 3 all squared plus y minus 2 all squared will equal 4 squared. There we go. And that's going to give us simply our equation here, and I suppose better to write that out as x minus 3 squared plus y minus 2 all squared equals 16. So that's going to give us simply writing down the equation of a circle given a couple of bits of data. Similarly, we can work out perhaps something about this circle if we're given this type of equation. So let's choose another one. Let's just choose, something like x minus 3 squared plus y minus 4 all squared equals 25. So if we're asked to try and work out what is this, basically we can work out what the center of our circle is going to be. Now, to work out the center of this circle, it's going to be simply, we've got our numbers here, and we're going to need to change the sign here, so it's going to be, looking at the wrong one, it's going to be 3 and 4 for our center of our circle, and to work out the radius is simply going to be the square root of 25, which is obviously 5. So we can flip from one to the other really remarkably easy. If we're told various simple things, we can work out various bits and pieces of this circle and its equation. So there's only so many ways we can sort of get these things arranged to give us basic ideas what we can do. So not really that difficult. Let's take a circle. The equation of the circle can be written in another way. We've got something like this. We've got x minus a all squared, and I've got plus y minus b all squared, and this equals r squared. Let's multiply this out and see what happens. So I've now got x squared minus 2 ax plus a squared, and I've got then plus y squared minus 2by plus b squared equals r squared. And if I bring that round, then we've got our equation of our circle. We can write in a little bit better. Let's put it in x squared plus y squared. So just rewriting this in perhaps a better order, minus the 2ax minus the 2by plus the b squared plus the a squared minus the r squared, and that will equal 0. And sometimes when we look at some of this, we can cheat a little bit. Now, what I could say is that this bit here could equal just a constant. So that could be just some sort of constant. And that enables us to have a different idea. Now, if we've got this thing here being true, the radius here could be written as the radius equals the square root of b squared here plus a squared minus our letter C. So we can get our circle in another manner. So let's suppose I'm given an equation to try and work out. So let's have an equation of a circle. Let's suppose we have here something like x squared plus y squared minus 14x plus 16y minus 12 equals 0. Can we find the centre of this circle and the radius of this circle? So what I need to try and do first off is, can I get this basically into the form of x minus a all squared plus y minus b all squared equaling r squared. Well, let's see what we can do. Let's basically put the x terms together. So I've got x squared minus 14x, and we've got our here y squared, and that one minus 12 equals 0. Okay, so we've got that there. Now let's see if we can now resolve this problem, and let's do that by first of all looking at this value, and what we're going to do is see if we can complete the square. So we've got our x squared minus 14x, so let's try and complete the square here. So that would be x, in this case, minus 14 over 2, which is going to give us 7, all squared, minus 14 over 2 all squared, which is going to give us 7 squared, which is 49. Let's do this for the other one. We've got y squared plus 16y, so this is going to give me x plus 8 all squared minus 64. So I've got these written out, so let's put these back into this first equation that we have up here. We'll try and put it back into there and see what we can get. I'm going to get here, substituting, then we're going to have my x minus 7 all squared, and I think we'll leave our minus 49 there because that's going to be a bit more obvious, plus here I wrote x there and that was y, plus y plus 8 all squared minus 64. So I've rewritten my x term, I've written my y term. Now let's put in our minus 12, and that equals 0. Let's just get rid of these numbers onto the other side. So I've got now x minus 7 all squared plus y plus 8 all squared equals 125. And then that is going to be basically our coordinates. So we've got here, I've got 7 and minus 8, and we've got to work out what the radius is of that. So I need to work out, if you like, the square root of 125. The square root of 125 is going to be something like 5 root 5. So given quite what seems a horrible type of equation, simply by completing the square, and that one sometimes causes people problems, just to remember that it's going to be x minus b over 2 all squared minus b over 2 all squared. There's our formula, which I was using that one just to try and remember it, but there we are. Gives you some ideas of how we do that one. So that gives us then an idea about how we can try and do some things with circles. But let's look at perhaps the main problem with circles that we're going to meet, and that's probably playing around with intersections and straight lines. So let's see what we're going to have with this circle. Alexa, stop. There we are. Stop the interruption before I get it. I've got a circle here. We can have various different points. Let's put in this one. It's a tangent. It's a tangent because I'm simply telling you it's a tangent. And I've got another line. If we've got a tangent, we will have just one point of intersection. If we have a line here going through a circle, then it will have 2 points. So this is just a line going through a circle, and this will have 2 points. And fairly obviously, but it needs stating, if I have another line and it has no points of intersection, then it obviously just doesn't touch the circle. So how do we go about working out here where this line is? So let's imagine we've got a circle with an equation of a circle, and we have a line that meets this. So we can choose an equation for this line. Let's see, that looks something like y equals 2x. Let's go for minus 3. And we're going to have a circle, and let's choose this circle is going to be x squared plus, I don't have to have it in the center, let's move it up a little, up or down a little bit, y. I think I'm going to have to go to minus 2. I was just going to put plus 2, but I think I'm going to have to go to minus 2 and let's choose a suitable radius 5. Problem making these up, this may not actually hit the circle. So what have we got? Well, I've got my value of y here. I know what value of y is, so we could just substitute this in there. So I've got x squared plus 2x minus 3 minus 2 all squared equals 25. I suppose we ought to try and work out what this one's going to be. So this is going to be x squared plus 2x minus 5 all squared equals 25, and we should be able to then work out what this is going to be. So we've got x squared plus, squaring this one out is going to give me 4x squared. I'm going to have 2 times minus 5, which is going to give us minus 10. So that's going to give us minus 20x plus 25 here. Bring that one over, minus the 25 equals 0. Solve this. This is going to give me 5x squared minus 20x equals 0. And I've got a nice one that I can just take a factor of x out, and so that's going to give me 5x minus 20 and indeed we can take a factor of 5 out as well. So that's going to give me, I wasn't looking, sorry, an equation there where we've got here simply, it looks like it's going to be a tangent, doesn't it? It's going to meet at x equals 4, and if I've got x equals 4, then we can simply fit this in to wherever we want to have and work out y, and there's no reason why we can't use this simple equation. So we can simply say that y equals 2 times 4 minus 3, so y equals 5. It's now going to meet at 1 point, so therefore we know my line here is a tangent. Bit scary doing some of those, simply because I made the numbers up and then I hoped and prayed it was actually going to fit. So what tangent and curve, tangent, chord, segment properties do we know, and what can it do with these? Let's draw in a circle, and what do we know? Well, we know that if I draw in a tangent, then if the tangent touches the circle, it's going to have a radius here. We do it 90 degrees, and that will go through the center. It is going to be a radius because they're perpendicular. Another property that we know of a circle is that if I take the center of the circle and draw a line from the center of the circle, and this basically bisects a chord, then that will also be 90 degrees. So perpendicular bisector we know goes through the centre, which is one of the points we actually said at the start. What other nasties can we have? Well, typically they're going to choose all sorts of horrible problems for you, where you can have all sorts of nasty things about circles, and you have to say whether a line's going to be on there or a line's not going to be on there, or whether it's going to fit or whether it's not, and you have to sort of have all sorts of nasty little problems to try and solve. Well, let's see if we can have a go at solving one of these sort of problems and see what we can do about it. So let's choose again a little circle, and let's have on this circle a triangle. So let's throw in some sort of triangle. There we are. Let's give this triangle some points. So let's call this one A, B and C, and we've got to give these some numbers: -8 and 1, 4 and 5, and -4 and 9. So we've got these. This is a circum circle. We know we've got a triangle. We know these points are going to fit on the circle. Each of these points are going to have a circle to go around it, and we're going to try and show that this is going to be the diameter. You can see obviously from me drawing out it's not, but that's my lousy diagram. So what sort of things could we do to try and show that this is a diameter? Well, you know from your circle theorems that basically if AB is a diameter, then we know that angle here ACB will equal 90 degrees. How can we verify that easily? Well, let's use Pythagoras, and we can use Pythagoras on those two lines to see if it equals that. So I know that AB squared is going to equal, let's think about trying to draw this line in. So it's going to be here 4 minus 8 all squared plus 5 minus 1 here all squared. So that's going to give us 12 squared plus 6 squared, and that's going to give me 144 plus 36, which is going to give me, that's going to give me 4 squared, isn't it? It's going to give me 16. Yep, that's going to give me 160. Right, let's look at AC squared. AC squared is going to be minus 4 up there, minus 4, and that's going to be minus 8 all squared, plus I've got 9 and 1, so that's going to be 9 minus 1 all squared. That's going to be the same as 4 squared plus 8 squared. That's going to be 16 plus 64 is going to give me 80. Okay. Let's look at the other line. Let's do BC
Here is a catch.
squared.
The book,
Alexa,
quote,
stop. Thank you. Do hate machines that interrupt. Let's do BC squared here. BC squared then is going to be, looking at it, it's going to be minus 4 minus another 4. Squared plus 9 minus 5 all squared. That's going to give me minus 8 squared plus 4 squared. That's going to give me again 64 plus 16 gives me 80. And so we've got from that and the other one, I can say that AC squared, which is 80, plus B squared, BC squared, which is 80, is going to equal a B squared, which is 160. So they add up. So the triangle is a right angle triangle. Doesn't look like it. And I have now managed to work out that AB is a diameter. How would you find perhaps the midpoint of this circle to find the equation? Well, if we know that point here is a diameter, then finding the midpoint will find me the equation of the circle, and we've done one of those already. So we can work out, even with quite nasty problems, some sort of ways of working out some nasty circle things. There are of course lots of problems that we can try and have a go at doing this, and what I'm trying to do here is just show you some of the ways that we can sort of learn how to do some of the bits and pieces. I'm not going through solving the problems as yet, but if you tune in and come back later, then I will start going through trying to find some easy tricks and ways of trying to solve some of these problems. So thank you for watching. I hope you enjoyed this and learned a little bit. If it was useful, then please subscribe, and I'll see you next week when we'll look at some more A-level maths topic by topic. Take care. Bye bye.